This is me playing the Chrome Dino game without touching my keyboard at all. Just by blinking, I'm able to make a little dinosaur jump on a screen. And before you think this is really small, here are clips of individuals all around the world who are doing things just like this. They're using their mind to control things all around them. And over the last couple of months, I've been working on a project that allows me to take any keyboard command and simply do it just by blinking. So that means I'm able to play the Chrome Dino game, but also navigate through Google Slides, move in between tabs, and even scroll down a web page. And this is all possible through this technology called brain-computer interfaces. And in the project I've been working on, it's broken down into a series of steps, and this reflects the way that BCIs work. The first step is to actually collect this information. It's to collect these brain signals, and this is done through the muse headband. The muse headband is intended for meditation, but what's really nice about it are these EEG electrodes. And this allows us to actually collect these brain signals and these brain waves and be able to use them. And so in this project, it's used in a Python code. So to actually connect the Muse headband with my computer, I use this app called Pedal Metrics, which basically uses Bluetooth, so I'm able to extract these signals while also transferring them onto my computer. And so at this point, we already have a way of actually collecting this information and sending it off to my computer. But the next step is visualizing my brainwaves. It's visualizing these neural activities. And this is done just through a code. And so this code is a repository from GitHub, and it contains a series of steps. What it does is it basically takes in this information and it sorts and filters through it. So firstly, let's begin with actually visualizing what's happening. And now I'll be breaking down the code that is actually present while also showing how we can visualize what's happening inside of our brains. So currently, as I mentioned before, this code extracts the data and filters and sorts through it. And so to start off, to actually visualize what's happening, we can go down into the terminal and type in muse lsl view. And this will open up a graph that allows us to connect to each of the electrodes that are here and be able to visualize how it's detecting blinks. So make sure it is on securely, and the main one we're going to be looking at is the blue line here. And so each time I blink, you can see that there is a spike. So for a while, I'm just going to stop talking because that does interfere as well. But if you just look now at the blue line, there should be small dips as soon as I blink. So you could see there were two right there. And then each of these little dips that goes down is representing a blink. And so this is really fascinating because using this, we're actually able to let the code know how to detect it and then use it to output certain commands. And so the next step is actually being able to classify this data that's being collected. And this is mainly done through this code right here near the bottom. And what it does is that the current value is set at a threshold, which is 1 in this instance. When the value does go above 1, it detects it as a blink. And we can see it because actually looking at the code, if I press play, you'll be able to see on the terminal, each time I do blink, it will type in blink and the numbers will actually be above 1. So there you can see each time I do blink, it detects it's the blink because it goes above that threshold. And so at this point, I've been able to classify this command. And now it's about creating this feedback loop. So it does extract this data, it detects a blink, and what now? So now I'm able to do it as you might see in any type of Python code, which is I'm able to set a command. So here I'm able to use this to press the down arrow key. So each time I blink, it will press the down arrow key for the code. So let's actually see this working on a real live website. So if I go ahead and click play, and I have this example one right over here, each time I'm blinking, you can see that it's going down. And with this, you can see that there are some instances where I don't blink but I'm talking and it interferes. And this can be quite common because the way that I'm looking at these blinks is specifically through the alpha wave frequency. But this doesn't mean that the alpha waves are only corresponding to the blinks. Alpha waves respond to how much we are in a certain type of relaxation mode. And what the thing is really important here is that our blinks become really sensitive to these alpha waves. So these alpha waves are really sensitive to them. So when we do blink, there is a change in their value. And so sometimes when I'm talking or I'm moving around, it can also manipulate these changes, which is why we have to be really concentrated and almost focused and not moving around too much when we're actually executing this. But keep in mind as well, this is an non-invasive type of BCIs. With more invasive types that might require surgery, they're right near the brain and they tend to be more accurate. But this is also a much more safer option to do as well. So at this point, we have been able to set a certain command, but we're not just limited here. We can set it to click the space arrow key, and this will allow us to virtually do any kind of activity that requires the spacebar. So in this instance, this is actually the Chrome Dino game. So if I go ahead and click play again, and a little montage of me just playing the Chrome Dino game. But as you can see, this does take a while to get used to and become familiar with the moment that it takes to blink and actually register that and actually output it as a command. And this is not only the thing that we're limited to, we can also change the command to click the down arrow key as well. So if we go down here as well, this will allow us to use it in any type of presentation format, for example, like Google Slides. So if I hit run and I head over to an example Google Slide presentation, and among that, a thing you might have noticed is how it went through two slides at once. And this is something that was used within the Chrome Dino game, which is the time it takes to actually register and detect a blink to when it actually outputs a command can take some time. So there's also the second portion of this code here where what it does is if it does exceed a certain limit, a certain threshold as well. So a key thing I noticed is that if you blink twice, it tends to go above 1.5. Then if you do blink twice, then it'll detect that. Or if it's a really powerful and a strong blink that tends to go above the threshold, it might click the certain command such as the down arrow key twice as well. One of the main challenges I did face with this code was actually in terms of the delay that would occur in terms of how this EEG data was being collected and when it was being outputted as a command. And it was basically the cycle that would happen and how often this cycle would update. And so one of the things that I realized was this number right here where you can see 0.9, this affects its ability of how often it's going to be updating and doing those cycles in terms of seconds. And this number does become subtracted by 1 over here in this code, meaning that 0.9 is really the only highest number because it can't be 1. And so 0.9 was the only highest number in terms of how often it would cycle. And you can see this when we change it to say 0.5 and we run the code. You can see that it's much slower as compared to the speed it would be if I set it to 0.9. And so this is one of the ways I could make sure that the cycles that were happening were becoming more accurate in terms of when I was blinking and when it was actually being set up as a command. One of the key potentials of BCIs in the recurring world is the potential they have for individuals who have limited accessibility. It's those individuals who have been told their entire life they won't be able to do anything because of a certain disability. And through BCIs, they're able to find a more effective means of being able to express themselves and communicate with those around them. We have certain tools such as wheelchairs and adaptive tools, but by using BCIs, we're also able to aim for more accuracy as well as it looks into these brain signals. And it's not just looking at brain waves itself. There are several different types of BCIs that might be invasive, which require surgery, and they're right near the brain, or semi-invasive as well, or non-invasive like the one in this project. So there are so many different types of BCIs out there, and they each have their own function and advantages. But if you look within all these individuals that are using them, it's crazy how they're doing things they would have never imagined was possible. You can also look into EMGs, which look at the muscle signals, and it shows us that the body itself is like a computer, and we can actually extract and collect these signals, and it allows us to make adaptive tools much more effective because we're able to connect them to the body. The body itself has so many activities going on daily that sometimes we easily miss. The fact that even a blink has so much potential is crazy to me. And this project itself, using these blinks to be able to control my whole keyboard, was amazing. And don't just take my word for it, try it yourself as well. In my next video, I'll be working on another project which looks at how we can use these blinks that are being detected to be able to take pictures, so through a blink detected camera.